Let's learn the introduction to artificial intelligence today. Hey, welcome back to the AI introduction class. Today we will learn about machine learning. In this session, let's look at the concepts of machine learning, and then we will learning the classifications of machine learning first. Let's have a short overview of its concepts and its history. So, machine learning is a technology in the field of artificial intelligence that enables computers to learn and improve their performance without being explicitly programmed. It uses computer algorithms and statistical models to analyze and learn from data, enabling computers to recognize patterns and make predictions or classifications on new unknown data. The concept of machine learning was first proposed by American computer scientist Arthur Samuel in the 1950s. According to him, machine learning is a field that gives computers the ability to learn without being explicitly programmed. In the first stage, which begins in the 1950s and lasts until the 1970s, researchers focused on developing algorithms that could learn from data. They aimed to create machines that could automatically improve their performance by analyzing and adapting to new information. In the second stage, which begins in the 1980s, saw a renewed interest in machine learning as the researchers developed more advanced algorithms and began to explore new applications such as natural language processing and image recognition. During this time, neural networks and deep learning began to emerge as powerful tools for processing and analyzing large data sets. The third and current stage of machine learning begins in the early 20th centuries and is characterized by the proliferations of big data and the development of new machine learning algorithms that can handle vast amounts of data. With the rise of cloud computing and distributed computing, researchers are able to analyze massive datasets and develop increasingly sophisticated models that can make accurate predictions and decisions in a wide range of fields, from healthcare to finance and to autonomous driving. Machine learning has a bright future in a variety of fields, including data analysis, data mining, pattern recognition, and other broad areas. In data analysis and data mining, machine learning can help business and organizations extract valuable insights and patterns from large data sets, leading to better decision-making and increased efficiency. In pattern recognition, machine learning can be used to develop algorithms that can identify and categorize patterns in data such as image and speech. And in broad areas, machine learning has the potential to transform fields such as healthcare, finance, and transportation by enabling predictive analytics, personalized medicines, fraud detections, and autonomous vehicles. Now that we understand what machine learning is, let's take a look at the different types of machine learning. Supervised learning is a type of machine learning where we use labeled data to train a model to make predictions on a new unlabeled data. Basically, we teach the algorithm to map input to output by showing a bunch of examples where we know the correct answer. The algorithms learn from these examples by adjusting its parameters to minimize the difference between its predicted outputs and the true outputs. We use supervised learning for tasks like image recognition, natural language processing, and predicting house price. Unsupervised learning is a type of machine learning where we try to find hidden patterns or structures in data without knowing the correct answers or labels. The algorithm has to figure out by itself what the pattern or relationship might be. Some examples of unsupervised learning include clustering and dimensionality reduction. Clustering is where algorithms group the data into similar subsets, while dimensionality reduction transforms the data into a lower dimensional representation while keeping the important features of the original data. Unsupervised learning is often used for exploratory data analysis and data pre-processing. It can help us identify outliers, discover potential correlations and structures, and pre-process data before supervised learning. Semi-supervised learning is a type of machine learning that falls somewhere between supervised and unsupervised learning. In semi-supervised learning, we use small amount of labeled data along with a large amount of unlabeled data to train our model. Labeled data is usually harder and more expensive to obtain than unlabeled data. During training, the model uses the labeled data to learn patterns or for classification or regressions, and also uses the unlabeled data to improve its performance. Semi-supervised learning is often used for tasks where we have large amounts of data, but only a small portion of it is labeled, such as NLP mission and image classification. It can improve the model's performance and generation ability while reducing the cost of labeled data. Transfer learning is a type of machine learning method that aims to transfer nerded knowledge to new and related tasks. This can be done by fine-tuning the pre-trained model's weights, using it as a feature extractors, or combine it with a new model. For example, we can use a pre-trained model on a large image dataset to perform a new image classification task, or use a pre-trained model on an English dataset to handle a new natural language processing task. Reinforcement learning is a type of machine learning method used to solve sequential decision-making problems caused by the interaction between environment and an agent. In reinforcement learning, the agent interacts with the environment to maximize its long-term cumulative rewards. After taking an action, the agent receives a reward or punishment signal and adjusts strategies based on its signals to perform better in future tasks. The goal of reinforcement learning is to learn an optimal policy that enables the agent to maximize its reward while interacting with the environment. Reinforcement learning has a wide range of applications in many fields, such as gaming, robotics, natural language processing, and more. It can solve problems that cannot be solved by traditional supervised or unsupervised learning methods. Alright, so that's what we need to know about the basic concepts of machine learning. In this class, we'll go deeper into the algorithms of machine learning, and see you again.